We are back, and now we're going to talk about the brain. So let's take a look at our study guide. The coverings of the brain and the spinal cord. There are three coverings. Why? Because your brain is about the consistency of oatmeal. Okay? So your brain by itself would not stand a chance sitting on top of your neck. Alrighty? It needs a skull to protect it. We talked about that in the bone chapter. But your brain itself also needs some internal protection on the inside. And we have three layers of connective tissue over the brain. So let's take a quick look. The outer covering is called the dura mater, which means tough mother. It is tough. When we dissect the brain, you'll be able to see in 210 that it's almost like plastic. You pull on it, you can't even tear it. That's how tough that mother is. Alrighty? Then there's a space underneath called the subdural space. The next covering is called the spider mother. You know, arachnophobia, arachnoid mother. Why? Because it's clear, and what do you see underneath it? All of your blood vessels. It looks like a spider web. Alrighty? So below that, where the blood vessels are, is called the subarachnoid space. And then we have the last layer, which is very thin and is actually touching the brain, and that's called the gentle mother, the pia mater. All right? Now, why is this clinically important for us to know? That if the blood vessels here break and it fills up, how far up can I push this?
Not very far.
Not very. Your skull is right there. So if this fills up with blood, it's going to actually push down on your brain, causing permanent brain damage. Below your dura mater is a large dural sinus, which is where all the venous blood is. What if that breaks? A subdural hematoma. I can't push any higher than this, so I push down, causing damage to the brain underneath. Okay? And that's why any kind of brain hemorrhage is life and death. Got it? You can't fool around with that. Even a brain bruise, like hitting your head during a football game and getting a concussion, is dangerous. Because again, you've damaged some of the brain cells. And that's why now we have concussion protocols. You get concussed, everybody jumps on you, and they get up, and you're like still laying there on the ground. Boom, off we go to have x-rays and CAT scans and whatnot, and you can't play the rest of that game, and if it's bad enough, you don't play for the next couple of games. Does that make sense? Just to protect your brain, all right? Okay, so that's that. Now next, the difference between nerves and tracts. I don't have a model of it, but I'll tell you. The white myelinated nerves that go down your arm or down your leg are called nerves. Makes sense? Sciatic nerve, femoral nerve, brachial nerve. Got it? Radial nerve, ulnar nerve. Got it? So if you see it in your arms and legs, we call that a nerve. Alrighty? It's actually made up of a bundle of a bunch of axons, both sensory and motor. Alright? Contrast that to the white axons going up and down your spinal cord. They're called tracts. So if it's in your brain and if it's in your spinal cord, we don't call those nerves, we call them tracts. Bundles of axons are called tracts. Fair enough? That's the end of that. Whenever we are looking at a brain, I have to hold these together with a rubber band. You see how we have bulges and in between little indentations, right? Each bulge or ridge is called a gyrus, gyri for plural, and every one of these indentations is called a sulcus or sulci, all right? But you also have, and we call the outside of this the cerebral cortex, all righty? Mm-hmm. And what do we call this sticking out the bottom? The medulla oblongata. Now we need to keep in mind the word cortex means to the outside, medulla means to the inside for any organ. Okay? You've got a cortex and a medulla in your adrenal gland, and a cortex and a medulla in your lymph nodes, etc. Okay? But that's what it means. To the outside, to the inside. Cool? Okay. What and where are the 5 lobes of your brain? Well, here we go. I'll have to take this apart a little bit. Hopefully it'll stay together. Okay, you ready? These 2 in the front, what do you think? Frontal lobes, yeah. These 2 on the side, temporal, where your temples are. And also, what bone is here? Frontal bone. What bone is here? Temporal bone. How about that? What do we call these 2 high up on the sides?
Occipital? No.
Parietal.
Parietal.
Because your bones up here are the parietal bones. Now, what do we call the 2 in the back?
Occipital.
That's occipital, at the back of your head. 10-4? Well, that's only 1, 2, 3, 4. I thought it said there's 5. Well, there is. If I open this bad boy up, and I hold my medulla, there's 2 more lobes here. Those are internal lobes called the insula. Okay? The insula, because they're on the inside. See how they're up underneath? They're inside. Okay? Oh, which reminds me. You see this hollow space here? And you see this hollow space here? If I put these 2 guys together, I'm fine. I'll walk back. These are my ventricles. These are the hollow spaces full of fluid. Now, this fluid, they injected plastic into it. But you see, they fit right here. Got it? Mm-hmm. That is where the 2 lateral ventricles are. And then they come together here. I don't know if you can see this. To me, it looks like a chicken head with a beak and a little eyeball. Okay, that's your 3rd ventricle. Then you have this little canal here and a 4th ventricle. And at the end of this is your spinal cord going down and back up. And it's what kind of cells are pushing the fluid around?
The I know they have cilia.
Cilia. The ependymal cells.
Ependymal
The
cells,
ependymal cells. Got it? But that's where it is.
Gotcha.
Do you see the pink underneath here?
Mm-hmm.
And the pink on top here? Those are the blood vessels that actually leak the cerebral spinal fluid. Because your cerebral spinal fluid comes from the plasma of your blood. It just has a different consistency. And of course, no red and white blood cells. 10-4? All right. Okay, we did this one in class with our brain hats. So take a look at what you did on your brain hat, and you'll get that, the primary areas. But I do want to make sure you know this. Compare the motor and sensory areas of your brain and spinal cord. It's very simple the way nature has set it up. There's a main sulcus here. It's called the central sulcus. It separates the front from the back. From here forward, it's all motor. From here back, it's all sensory. And here's the cool thing. On my test, if I say, where are the motor tracks of your spinal cord? They're in the front, just like the front of your brain is motor. Where are the sensory tracks? In the back, just like your brain. That's what I'm saying. Your spinal cord is just an extension of your brain. Okay? Your brain is like a cauliflower, and then the stalk of the cauliflower is your spinal cord. Okay? And your medulla oblongata. 10-4? All right. So that's how we compare the sensory and motor areas of the brain and the spinal cord. All right? Okay. So let's take a look at the rest of these parts of the brain. I think we know what this is. That's your ventricle, the hollow spaces with the cerebral spinal fluid. All right, next let's look at thalamus and hypothalamus, shall we? Let's take a look at this model. All right. Ready? Do you see a chicken head with a chicken beak?
Mm-hmm.
Okay. The chicken head is the thalamus. The chicken beak is the hypothalamus. Hanging down from the hypothalamus would be your pituitary gland, which we don't have on here. Okay? Are you with me?
Yep.
All right. So, on my lab test, I'll say, what's this? Chicken head. You say thalamus. What's this? Beak area. Hypothalamus. Got it? On my chapter test, I'm going to ask you, what's the function? Well, if you remember, we drew this picture, but I might do it again. This thalamus, and we have two of them. Okay? Do you see back here these two bumps?
Mm-hmm.
That's your thalami. There's two of them. And if you look over here, can you see the chicken head and the chicken beak right there? Okay, so that is, there's two of them. It goes like here. That thalamus is this big oblong thing here. Alrighty? The thalamus, or the thalami, because there's two of them, is the main relay center for sending messages into your brain and sending messages out of your brain. Okay, in a few minutes, hey, want me to draw it right now? I'll do it right now. Come on over there. Here we go. Here we go. All right. See, here's your brain. Okay, here's your brain on drugs. No, here's your brain. And sitting in the middle of your brain are these two oblong things called the thalami. Okay? Sitting out here in the front is your chicken beak, the hypothalamus. But I'm worried, not worried, but I want to talk about the thalamus. 10-4? All right. What did we say the front of your brain was all about?
Motor.
Motor. Okay? And this area here is the primary motor. That's first degree. Right there. And right behind it is the primary what? Sensory. Primary sensory and the primary motor. Okay? First degree motor. Primary. Alright? Okay. Now let's draw the rest of our friend here. We have our pons, we have the medulla oblongata, and as we go down, let's draw somebody's hand, which looks horrible, but there it is, okay? All right. Ow! Somebody put a splinter in my finger. Got it? Okay. Well, we're going to use blue for sensory. We pick up the information on a sensory neuron, and that synapses here into the spinal cord. We pick this up, and we synapse here in the thalamus. And then we pick this information up, and we synapse in the sensory cortex, okay? In your cerebral cortex. How many neurons does it take to get the message out to your brain? Exactly 3. 3 sensories in a row. Big long one to your spinal cord, big long one up your spinal cord, and then a shorter one in your brain. 10-4? Okay. In your brain, we make the decision. Yeah, that was owie. We need to do something about it. So, we have a motor neuron. Can you see that? I'll tell you what, I'll use this one. We have a motor neuron here, and it's going to synapse where? In the thalamus again. And from here, we're going to send it down the motor part of the motor track, where it's going to synapse with the next one that's going to go to your wrist, for example, and say, pull your hand away. So how many motor neurons does it take to move your hand? 3. Okay? 1, 2, 3 in, 1, 2, 3 out. Okay? G, where are all the sensory tracts? In the dorsal part, the back of your spinal cord. Where are all the motor parts? In the front, just like your brain. Isn't that cool? Isn't that nice and easy to remember? Okay, so what is the purpose of the thalamus? It is the relay station in the middle of all incoming and all outgoing impulses.
Control center.
It's the control center. Okay? It has to be aware. In fact, you know what we call this? The reptilian brain. Because do you think lizards are thinking about Shakespeare? And, and mythology and, movies? No, we do. So our cortex is a lot bigger than a reptile's. Does that make sense? Okay, that's why we do that. Okay. Now remember, we had our chicken beak here in the front. That's your hypothalamus. Hanging down from that is your pituitary, and coming near that is your optic nerve with your eyeballs. Okay? All right. We'll worry about eyeballs later. What is the job of the hypothalamus? Even though he's very little, it's important. It's your temperature regulation. It is your breathing regulation. It is hunger and thirst. It is all sorts of life-preserving homeostatic functions. All right? So that's what you're going to be answering on your chapter test. All right? Now, here in your medulla oblongata, we have a cardiovascular center, which tells your heart to beat and how fast. It also helps regulate your blood pressure. The pons, and that's this. Let's see if we can see it. See that little belly-looking area sticking out here?
Mm-hmm.
That's the pons, and that's the medulla. Okay? And down inside here, down inside the pons and the medulla, is where we have our cardiovascular center and our pulmonary centers. Okay? So, the pons has a very important job dealing with your breathing. Okay, it helps to regulate and how and smooth out your breathing. But here, next to the cardiovascular center, is the main area that says set up your breathing pattern. Okay? All right. Cool beans? Got that? All right. Let's see. What else do I need to know? Oh, here we go. The limbic system. And its main player, the hippocampus. The main player is the hippocampus. So what is your limbic system? It's your emotional system. It's in charge of being happy or depressed or scared or angry. All of that is run through various parts in your brain together called the limbic system. Now, in my opinion, the main player is a little shrimp-shaped character. There's two of them, one on each side. A little shrimp, and let's see if we can find Mr. Shrimp in here. Yes, there he is. Come on. All right. See, this is the temporal lobes here. If I turn it over, I don't know if you can see this. Do you see a little shrimp right here?
Yeah.
Okay, and here he is again, but he's got some blood vessels on top of him.
Mm-hmm.
But that's the main character right there, that little shrimp. See him?
Mm-hmm.
Okay. He's kind of curved.
Yeah.
All right. When we dissect this, you'll be able to hold him in your hand. What is the hippocampus all about? Hippocampus means seahorse, believe it or not. Okay, hippo means horse and campus means seahorse. If he is upset, nothing can be learned. If he is quiet and happy, everything can be learned. He's the gateway to learning. Okay? Have you ever been blanked out on a test? Sure. I bet you studied the day before the test or the day of the test. Why is that never a good idea? Because if you're having to look at your notes one more time, guess what you're telling your hippocampus? Everything I did last week, I've already forgot. I got to start over again. And that makes your hippocampus freak out. And when he's freaked out during a test, nothing can come out. That's why you blank out. Anybody ever have a bad grade on a test, and as soon as you turn in your test, all of a sudden all the answers flood back into your brain? Because now the hippocampus is quiet. Hey, the danger is over. The test is done. Now all of a sudden I remember everything. Okay? So I just want to mention this to you because it's best not to cram the night before or the morning of the test. All you're going to do is discombobulate Mr. Hippocampus. He wants everything to be quiet. Okay? And when you study, you need to study when you're not worried. Okay? When you're not, got it? Which means, if it's 2 o'clock in the morning and you're dead tired, do you think the hippocampus is happy? Don't study then. Okay? Same thing, but don't study the night before the morning of, because the closer you get to your test, the more anxious Mr. Hippocampus is. Does that make sense? You want to study way in advance. Got it? 2 weeks ago, you should have done chapter 6 and 7. Last week should have been chapter 8 or whatever. This week is chapter 9. Does that make sense? That's how you study. That's why you have a chapter or so each week to study. Get it done then. Something else that you need to be aware of. Your hippocampus, like I said, doesn't like to be tired. If he's tired, he's going to rebel by shutting down. All right? So you'll know you're shutting down because you're reading your notes and you just can't stay awake. Well, what does that mean? Push through it? It means stop. Get away from it. Go take a nap or something if you're that tired. But my suggestion is don't ever study for 3, 4, 5 hours straight. You want to study for 20 or 30 minutes. Take a 10-minute break. 20 or 30 minutes. Take another break. Why do you think I keep saying to my students, put your information on flashcards or a Quizlet? Can't you go through 20 of them in 20 minutes? Good. Then walk away from it for a while. Then do another 20 minutes. Got it? Now, putting all your notes on cards, that might take 3 hours. But when you're writing your notes, you're not studying. Same thing. Watching my video, you're not studying. You're simply taking in the information. Got it? When you're sitting in class, you're not studying. You're simply taking in the information. Studying is, okay, now how am I going to get that information in here? And that's why if you're a rewrite, you rewrite your notes. If you're auditory, you listen to the videos. If you're kinesthetic, you teach it to somebody. Does that make sense? Or you use the flashcards and walk around like we did last week. All right? So, you want to keep Mr. Hippocampus happy. 10-4? All right, now what is this? Well, we got the pons. Don't worry about the reticular formation. We'll skip him until 210. Can't do it all, folks. Can't do it all. Okay, we got the pons, the belly. We got the medulla in the middle and oblong shaped. Now, who is this? That's this guy. Can you see him?
Mm-hmm.
He's this little brown donut-looking thing in the back of your head. Okay? And when you open it up, do you see a little white tree? That's called the arbor vitae, or the tree of life. Okay? All of this is little nerve tracks. Okay? What is the job of this guy? Oops, by the way, we call this the cerebrum, and this is the cerebellum. Don't confuse the two. What's the purpose of the cerebellum?
Balance.
Balance while moving. Got it? It's constantly keeping track of your knees and your ankles and your hips and your arms and even your head to make sure you're balanced. Got it? Think about this. Is it easier to walk a straight line when your head is crooked or when your head is straight?
Straight.
Got it? And how about if you're trying to walk a tightrope? Do you just go like, or do you have to go like this? See how your arms help you balance. You don't even realize it, but when you're walking, you are actually swinging your arms slightly. Got it? All of that information is going into your cerebellum to make sure you don't take the next step and fall. Okay? So that's the job of the cerebellum. So we got the jobs in good shape? Okay. 12 cranial nerves. Folks, that's way too much for this test. Alrighty? You will have to know them forward, backwards in nursing school and in 210. But this is 112. So at the moment, I've given you all 12. Okay? You got the sheet with all 12, what they do. Okay? But how about for this test? And I promise you, you'll have more on each test afterwards. Okay? But for this particular test, let's make sure we know cranial nerve number 1, number 2, and number 3. They're named for farthest and coming back towards the brain this way and then going down the medulla oblongata. The furthest one out are these two. In the front of your frontal lobe. Can you see these two white Q-tips? That is called your olfactory nerves. They are right over your nose.
That's cranial nerve number 1.
That's cranial nerve number 1. All right? Then, see these two sticking out right here? That's your optic nerve, cranial nerve number 2. Now, what's your olfactory help you do?
Smell.
What's optic help you do?
See.
Yeah. Now, look over here. If you look carefully, I don't know if you can see that right here. Do you see two little white nerves here?
Mm-hmm.
These two little white nerves here, right underneath the optic nerve, those are number 3. And guess what they're called? Ocular motor. I wonder what they're responsible for. Moving your eyes up, down, left, right. But see how it makes sense? It's right next to where your nerves are for seeing.
Mm-hmm.
Okay? And if you look, see all these other guys here? Those are the rest of the cranial nerves. See them over there? And we'll learn those as we go along. Okay? Don't have to kill yourself. I do want you to know one, it might be extra credit on your test. I think it's one of the most important cranial nerves. The vagus nerve. That's cranial nerve number 10. And it is the main parasympathetic nerve. It is all about rest and digest. It's the one that tells your heart, beat at 72 beats a minute. Even though your SA node and your AV node are fighting between 150. Okay? Your vagus nerve. Also, your vagus nerve is in charge of all your intestines and your stomach. So, it runs down behind your ears, goes down your neck, joins together with one branch to your heart and one branch to your stomach and all that kind of stuff, right? Okay. What's a neck rub going to do for you? Speed you up or slow you down?
Slow you down.
Exactly. Oh, I love it, right? Think about a kitty cat at your house or a dog at your house. What do they do when you scratch them behind the ear? You are literally stimulating the vagus nerve to send a message. Heart, slow down. And don't they?
Mm-hmm.
Okay. But at the same time, you're sending a message, digestive tract, speed up. Now, we don't see them, their stomach and everything, speeding up while we're scratching them behind the ear. But I did have a little kitty cat when I was a kid named Kimberly. She was a little Persian. And when I scratched her behind the ear, she would drool constantly. Now, as a kid, I'm going, oh, that's disgusting. Now, as an adult, I understand. I was stimulating her salivary glands because I was stimulating her vagus nerve. Rest and digest. Then 4. So, yes, the vagus nerve, very important. Okay? Rest and digest.
Cranial nerve number 10.
Cranial nerve number 10. Yes, indeed. And later on, we'll find out the number 8 is the for hearing. Okay? Et cetera, et cetera. All right? Let's see. Was there anything else I needed to know? Well, you know what? I've got time. You got a few minutes?
Mm-hmm.
Let me draw all of this. Hold on. Let me steady this, and I'm going to draw this on the board.
What y'all did with the hats?
Yeah, we'll talk about the hat. I'm not going to make it too hard. Where's the motor part of your brain? In the front. Where's the sensory part? In the back. So these are the parts we need to know. So let's walk over here. I'll make my brain a little bit bigger. You can see everything. Okay? And of course, here's the pons and the medulla. Got it? Okay. First things first, we need to understand that there is a central sulcus. A central sulcus that separates the front from the back. All right? And the front, we're going to use red because it's motor. Everything in the front is motor. So this first area right in the front, kind of where we were drawing earlier today, this is the primary motor cortex. Okay? Motor cortex. And it's primary because it's the main one. In front of that is our association area. Motor association. Let's see if we can explain what's going on. This main area says, move my hand. The association area helps smooth it out so I can pick up what I want to pick up without just shooting out. 10-4? Now something else that's very important is that if you have a stroke or you have some damage to your motor cortex and you can't move this arm anymore, with enough physical therapy, we can retrain the association area to take over. And that's why physical therapy works. That's why they offer physical therapy now in hospitals. Alrighty? So that's the next big thing people are going into. A lot of my students are going into physical therapy because there is a future in that. They realize if you have blunt force trauma or something, you can rehabilitate. Back in the old days, oh, you can't move anything? Yeah, just sit in a wheelchair and you're done. Now we realize there's a chance to get out of that wheelchair. There's a chance to actually move again. Occupational therapy, learn to go back to work. And physical therapy, learn to go feed yourself again. Got it? But that's what the association area is for. In front of this is called the frontal eye field. Okay? The frontal eye field. What does that mean? Do I see with this? No, because I'm in the motor area. This part of my brain tells me to move my eyes up, down, left, right. Because it's all about motor, motor, motor. Okay? Let's go over here to the blue side. The first area, like we drew earlier, this is your primary sensory cortex. And right behind that is another association area. This is your sensory association area. Okay? It helps your sensory. For example, your sensory says, yeah, I feel something with my hand, but my association area says, oh yeah, and it's smooth. Oh, and it's cool. Got it? Helps out. And again, if I have a stroke or some kind of damage with physical therapy, the association area could take over that particular function. Alrighty? Okay. Now I'm just going to put this in here in another color, but it's supposed to be blue. Alright? Right in the back of your head is the primary visual cortex. Yes, you see in the front, but it's the back of your brain that actually sees the picture. Okay? Alright. And guess what we have around that? A visual association area. Visual association. Now, let me tell you a quick story. My poor mom, in her later years, all of a sudden said, I can't see the TV. And we're going like, can you see my hand? Nothing. Couldn't see anything. Took her to the doctor. He goes, yeah, she apparently had a stroke in the occipital lobe, and now she's blind. So of course, we were going to take care of her, and we did. My sister and her husband, my wife and I, we took care of Mom, alrighty, for the next 5 years before she passed away. And one day, about 6-7 months later, she goes, turn on the TV. I want to watch the news. We go like, Mom, you can listen to the news, but you can't see the news. She goes, what are you talking about? Of course I can see. I said, really? How many fingers am I holding up? He goes, 2. I went, okay. What's this headline on the newspaper? What do you think happened? The association area filled in, and now she could see again. Okay? So your brain is a lot more complex than we ever thought of. All right? Now, I'm just going to use purple. I'll use pink to show you 2 special areas. There's a special area here in the front and a special area here in the back. Alrighty? Now this area here is auditory. That's for listening. But this area is very special. That's called Wernicke's region, and the words are spelled for you. And this area here is Broca's region. Broca and Wernicke are for speech and understanding speech. Which one is for making words?
The
Broca, because he's in the motor part. And which one is for understanding the spoken word? Wernicke, which of course is right next to the auditory, which is perfect. And the auditory is right on the other side of your ear canal. Got it? On your brain. That's perfect. But the Wernicke is special for understanding the spoken language. And if you are a translator, having to know multiple languages, these are highly developed in you. Cool beans? All right. Okay. Now, here is the last one, and that's this. You see all of this here in the front? See all of this right here? This is the prefrontal cortex. Right here in the front. I mean, very much in the front. Guess what happens here? Learning. Math. Okay? Comprehension. I can't spell. Comprehension. Gee, what part of my brain is all about learning? Sensory or motor?
motor.
See, that's why we're kinesthetic learners. The more we do it, the more we learn it. You don't learn by just passively hoping Mr. Weber says it to you, or passively looking at my videos. That's why I say, make notes, put them on flashcards, make them into Quizlets, and remind yourself using repetition, because doing is learning, okay? And that, you can't beat it. There it is, okay? All right, I think that pretty much covers our episode for today.